Welcome to our YouTube channel exploring the fascinating world of friction and motion. This video explains the concept of friction and how it affects the motion of objects. Whether you're a science buff, a student, or just curious about the forces that govern our daily lives, this video is for you. Friction is the fundamental force that occurs when two surfaces touch and interact. It plays an important role in determining how objects move and behave in our physical world. This video explains the concept of friction and its different types. First, we will cover the basics of friction, including its definition and how it is measured. We will discuss factors that affect friction, such as the nature of the surfaces in contact, the force with which they are pressed, and the surface roughness. We make these concepts easy to understand through engaging animations and real-world examples. Next, we examine different types of friction. We are interested in the static friction that keeps an object from moving when a force is applied. We also study kinetic friction, which affects when an object is already in motion. Through clear explanations and practical examples, it will help you understand the difference between these two types of friction and how they affect movement differently. Furthermore, we show how friction can be beneficial or harmful in different scenarios. From the grip between tires and the road to the brakes in our cars. Friction allows us to control and manipulate our movements. On the other hand, friction can affect efficiency and cause wear of moving parts. We will examine these contrasting aspects of friction and their effects on our daily lives. Finally, we conclude the video by summarizing the key points and giving a solid understanding of the relationship between friction and motion. Whether you're interested in sports, technology, or simply want to understand the world around you, this video provides a comprehensive overview of the role of friction in the dynamics of friction and movement. Don't forget to like this video, subscribe and hit the notification bell to stay updated on upcoming videos about exciting scientific concepts. Let us dive into the fascinating world of friction and motion together. The use of wheels makes it possible for a car to move from one place to another. The wheels, combined with the vehicle's engine and drivetrain, enable forward and reverse travel. I will briefly explain how this works. Automobiles typically have internal combustion engines or electric motors that generate electricity. This force is transmitted to the wheels to create motion. The tires are attached to the wheel hubs and give traction to the road surface. When power is transferred to the wheel hub, the tire pushes against the ground, creating a force that propels the car forward and backward. Finally, when the tires come into contact with the road surface, friction is created, which allows the car to grip the road surface and propel it forward. As the wheels rotate, they roll across the road, providing linear motion for the vehicle. So what is friction and what is its function? Let's understand. Friction between the car and the road can be explained by the interaction between the tires and the road surface. As the car moves, the tires deform due to the weight of the car and the forces exerted on the tires. This deformation creates a contact surface between the tire and the road surface. Pattern that provides grip, repels water and maintains contact with the road surface. The sidewalls of the tire also contribute to the overall stiffness and power transfer capability of the tire. The tread pattern on the tire surface is an important part of tire construction. This pattern includes various grooves, channels and sipes that help drain water, snow and dirt from the ground surface. By effectively controlling these factors, the tire structure improves the tire's ability to maintain contact with the road surface, prevent hydroplaning, and improve traction. The tread compound, a special rubber compound used in tire construction, plays an important role in friction. Different tire compounds have been developed to ensure the optimum balance of grip, durability, and rolling resistance. The choice of tread compound can be tailored to specific road conditions, temperatures, and performance requirements, thereby affecting the tire's frictional properties. The flexibility of a tire's sidewall structure affects its ability to transfer power between the road and the vehicle. A sidewall with just the right amount of flexibility allows the tire to follow the road, improve grip, and maximize tire contact patch. This flexibility allows the tire to conform to uneven surfaces and maintain a constant frictional force. The internal structure of the tire includes reinforcing layers such as steel belts and fabric plies. These layers give the tire strength and stability. The design and placement of these layers affect the tire's ability to withstand forces encountered during acceleration, braking and cornering. By maintaining tire shape and stability, proper tire construction ensures even and effective friction between the tire and the road surface. The weight of the vehicle on the tread of the tire determines the load capacity and stiffness of the tire. The even weight distribution optimizes the contact patch for better tire grip and traction. The friction between the tire and the road surface is mainly due to adhesion. Adhesion is caused by intermolecular forces between the tire rubber and road surface molecules. This grip helps maintain traction and keep the tire on the road when the tire and the road are in close contact. Traction is the force of friction that allows the tires to stick to the road surface and propel the vehicle forward. Proper traction is essential for acceleration and allows the tires to effectively transfer engine power to the road. When the driver applies the brakes, the vehicle slows down due to the friction between the tires and the road surface. Braking force is primarily generated by the adhesion between the tire and road surface, allowing the tire to grip and resist movement, effectively braking the vehicle. Grip is important for cornering and steering control. Tires need enough grip so that the driver's steering movements can be transferred to the road surface and the vehicle can change direction smoothly. Adhesion allows the tire to withstand lateral forces and maintain traction while cornering, allowing for precise control and stability. Prevents wheels from slipping and skidding, helping drivers follow their desired route and effectively respond to road conditions and obstacles. This allows the tire to maintain grip on a wide variety of surfaces and conditions, including wet, icy and uneven surfaces. With proper grip, tires can effectively transfer power, resist slippage, and make vehicle behavior predictable and controllable, thus minimizing the risk of accidents. Rolling friction is the predominant form of friction between a car's south tires and the road under normal driving conditions. It occurs when the tire rolls on the road surface, and deformation of the tire shape and energy loss occur due to hysteresis. Energy loss manifests itself in the form of heat, which leads to tire wear. Converts the rolling motion of the wheels into forward motion of the vehicle. As the tires roll on the road, the friction between the tires and the road propels the car forward. Rolling friction is generally lower than sliding friction, making the drive more energy efficient and allowing for smoother acceleration. This means that a significant portion of the engine's power is efficiently transferred to the road, improving fuel economy. Minimizing energy loss through friction improves overall performance and reduces vehicle operating costs. Rolling friction provides vehicle stability and control. This allows for smoother, more predictable movement and gives the driver better control over acceleration, braking and steering. Rolling friction helps dampen the vibrations and shocks experienced by the vehicle and its occupants. The interaction between the rolling tires and the road absorbs some of the shock, resulting in a smoother, more comfortable ride. This is particularly important for passenger comfort and reduced driver fatigue. Rolling friction produces less noise than sliding friction. The smooth rolling motion of the tires reduces the friction noise that occurs when they come in contact with the road surface. This results in a quieter ride, improving the overall driving experience and reducing noise pollution. Grip, or traction, between a tire and the road is affected by several factors, including road conditions, tire material, tire design, tire pressure, and vehicle weight distribution. Rough or bumpy surfaces may reduce grip, but smooth, dry surfaces will improve traction. Responsible for the traction between the tire and the road surface. Traction is essential for vehicle acceleration, braking and control. Tires with good grip can minimize wheel spin. Superior grip prevents loss of control, wheel slip and skidding. As a result, the vehicle maintains traction in adverse weather conditions such as rain, snow and ice. With proper grip, tires grip the road effectively, reducing the risk of accidents and increasing overall road safety. The grip between the tires and the road determines how quickly the vehicle comes to a stop when braking. Tires with higher grip can generate higher frictional forces, which can shorten braking distances and improve braking power. Superior grip improves the driver's ability to control vehicle movements, react to sudden changes and navigate different road conditions. Delivering a predictable and connected driving experience, giving drivers confidence and control. Tire grip is very important for adapting to different road conditions. Whether on dry, wet, or slippery surfaces, a tire's grip determines how well it maintains contact with the road surface and how well it reacts to changing conditions. High-grip tires expel water effectively, improving traction on wet roads and reducing the risk of hydroplaning. Exceeding available friction can cause tires to skid, causing loss of control. Slip occurs when the tires rotate faster or slower than the vehicle speed, such as during acceleration or braking. Skidding usually occurs when hard braking or excessive steering causes the tires to lose grip and skid across the road. The coefficient of friction is a measure of the grip between the tire and road surface. Expresses the ratio of frictional force to normal force weight acting on the tire. The coefficient of friction depends on road conditions: dry, wet, ice, etc., tire type, tire condition, and other factors. Concrete usually has a high coefficient of friction, resulting in better grip. On the other hand, wet, icy, or loose roads can significantly reduce the coefficient of friction, affecting a tire's grip and traction. Different types of tires have different coefficients of friction. For example, summer tires are typically designed for better grip on dry and wet roads, while winter tires are optimized for traction on snow and ice. A tire's tread pattern, rubber compound, and other design features can affect its coefficient of friction. On the other hand, worn or stripped tires have reduced traction and a lower coefficient of friction. Environmental variables such as temperature and humidity can affect the coefficient of friction. For example, cold temperatures can reduce tire grip and reduce the coefficient of friction. Additionally, factors such as road debris, oil spills, and loose gravel can change surface conditions and affect the coefficient of friction. It is important to note that the coefficient of friction can change dynamically under different driving conditions. For example, when you brake hard or accelerate, the force increases and the tire can slip, thus reducing the coefficient of friction. In addition, the coefficient of friction can change during cornering when lateral forces are acting.